Okay, what I want to do is consider the production of two goods, goods X and Y. Both will have constant returns to scale. We're going to assume Cobb-Douglas technologies, and we'll have one good be capital intensive relative to the other. So we're going to start off and we're going to define the two production functions as X equals the capital devoted to X raised to the power A times Lx, which is the amount of labor devoted to X raised to the 1 minus A. You know, the fact that A and 1 minus A add to 1 gives us constant returns to scale. Good Y will equal ky raised to the b times ly raised to the 1 minus b. All right. If A is less than b, then good Y will be capital intensive relative to good X. Okay, we define the marginal rates of technical substitution as the marginal product of labor divided by the marginal product of capital. So for good X, it's going to equal 1 minus A divided by A times the capital labor ratio in good X. And the marginal rate of technical substitution for good Y is going to equal 1 minus B over B times the capital devoted to good B divided by the labor devoted to good B, or the capital labor ratio. If we divide both sides by 1 minus A over A, we'll get the capital labor ratio in industry X will equal some constant W times the capital labor ratio in industry Y. And that constant W is 1 minus B times A divided by 1 minus A times B. Full employment says that the entire capital stock will be allocated to either the production of good X or good Y, or K prime equals KX plus KY. And also that the entire labor supply will be devoted either to the production of good X or good Y. Now we solve and we have, or we want to solve, and we have KX, as we see right here, equals W times KY times LX over LY. All right, we're going to substitute in our full employment of capital so that KY is equal to K minus KX. All right, KY is all the capital that is not devoted to the production of X times LX over LY. All right, and we're going to bring the KX term over to the left-hand side, and we get KX plus W times KXLX over LY equals W times the capital stock divided by the labor in X over the labor in Y. All right, I'm going to factor out from that left-hand side here a KX and come with a common denominator, and I get KX equals LY plus WLX divided by LY. All right, solving. All right, actually what I'll do is I'll take that LY term and recognize that the labor in industry Y is equal to the total labor supply divided by the labor devoted to industry X. So we have right now, solving for the capital stock in industry X, we get KX equals that weight W times the total capital stock times the labor devoted to X divided by the total labor stock plus that weight 1 minus, or W minus 1 times the labor devoted to X. So we have now solved for the amount of capital devoted to industry X as a function of the total stock of capital, the total stock of labor, and the amount of labor devoted to industry X. Okay, this is the contract curve, which maps out all technically efficient input bundles. All right, and I will see if I can't pull. Well, I guess what I'll do is I'll create a second video which shows how we can graph the contract curve and go to the production possibilities frontier. They want to limit this to 5 minutes, and my time is just about up.